Bom dia, João. Tudo bem?
Bom dia, can you hear me?
That's perfect. So,
Okay.
let's project the screen. View setting. Yes. Here, I think here we are. Yes. So, let me introduce you, please. So, João de Oliveira is Vice President Business Development at PragmatIC. So, João is an experienced commercial manager with a strong background in electronic engineering. Previously, XG Tag, part of the Cambridge Technology Group, he led business growth at over 30% annually from 2006 to 2012. João has held business development roles at Plastic Logic and ARM, where he initiated the business that evolved into the current secure segment activity. He's also fluent in 5 different languages, so I can only recount for 3. I can bet you for 3, but I'm sure you're amazing as well on the 2 others. But now, today it will be in English, and I give you the floor. Thank you, João.
Thank you, Chloe. Well, first of all, I would like to thank IntelliFlex for organizing the event and allowing me to present on behalf of PragmatIC. I will try over the next 15 minutes to give you an overview of PragmatIC, the company, the technology, some applications, and our roadmap as well. Next slide, please. Thank you. So PragmatIC is still in a startup, although we are 10 years old and over 100 people by now. We are based in Cambridge, UK, headquarters, and we also have our manufacturing plant in the north of the UK in Sedgefield. The main investors, shareholders of the company are of 3 different profiles, which is quite interesting. ARM, I don't think we need to present ARM. It's a very high-tech company based in Cambridge, and for us that's a very nice investor partner. The money was obviously nice when they invested in the company, but more than that, it was the vesting, the strong technical and commercial due diligence, both from the technology side and the manufacturing side, that was a very nice tick in the box for us. And they support us and help us technically to progress our technology. Avida Nissan as well, a big name in the apparels, labels, and materials industry. They have become the #1 inlay providers in HF, NFC, HF, after they acquired SmartTrack a few years ago. And they were already the biggest and first inlay provider in UHF in the world. So that's a nice combination. So that's an industrial partner and customer at the same time. And the third main investor is a national, local, regional VC entity that is very nice to have on board as well, that is helping us to grow strategically. Next slide, please. So this is just to try to depict a landscape background of our technology value proposition. So there's three major technological revolutions. The PC revolution on the left that happened around the 80s. So you had, this has changed the way we all do things on a daily basis, obviously. And you had a big main processor chip in there. The order of magnitude of the cost of that chip, we're talking hundreds of dollars for the chip, and the numbers were in the millions or few hundred millions per year. Then in the 90s came the smartphone revolution, followed by the tablets and the smartwatches and so on. So that was started in the 80s. The chips or the chips in those devices are in the order of the dollar. So the volumes obviously have increased tenfold or more, but the cost of the main device has gone the other way around. And now the third revolution that we are in, that started already some time ago, it's called the Internet of Things, the Internet of Everything, printed electronics, smart packaging, interactive packaging, and so on. So this addresses opportunities in the trillions. That's a strange number, but it's definitively trillions numbers opportunities. The caveat to that is that that can only happen in those volumes, at least, if the system cost is not 100, is not $1, but is in the cents or fractions of a cent for the electronics. So that's where pragmatic core business is. So we're not trying to compete with traditional electronics. We are trying to address and open up markets at volumes and costs that are not achievable with traditional electronics. So our core technology, so I do apologize because some of those slides may be a bit too technical and some of them may not be technical enough depending on who's listening. So our core technology is being able to process transistors on flexible substrates, to process them very accurately and with geometries that are outside of the traditional printing realm. So our processes are much simpler than traditional electronics and at much lower temperature points as well. But we are also still quite bigger than traditional electronics. Our transistors are sub-micron, which can seem very small, but compared to traditional electronics, which are in the nanos, 7 nano, 3 going through 3 nanos and so on, we are sub-micron, so we're a few hundred nanometers of geometries. But we are going down at the same time. So the fact that we can process transistors on low-cost flexible substrates allows us to create low-cost flexible electronics. So having said that, we have also to step back and state clearly that we're not as fast as traditional electronics, we're not as dense as traditional electronics, we're not as power efficient as traditional electronics, we're not as mature as traditional electronics. But for the functions we can achieve today, and we are improving every year, every day, for the functions we can achieve today, we are 10 to 20 times cheaper than traditional electronics. So the idea is that we're not trying to go head front against traditional electronics. We are trying to address applications, markets at volumes and cost points that traditional electronics will not be able to address. Next slide, thank you. So typically, we've been for some time talking to customers, brand owners, major companies around the world, and discussing with them projects, and then we design PragmatIC's. We integrate those PragmatIC's within systems to create prototypes, and then we start manufacturing the early prototypes, and then somebody else will do the integration in volume using our PragmatIC's. But of course, that's not scalable. So to address the fact that a lot of companies want to design using our electronics, we have created the PDK. That's something that is very generic in the electronic industry that allows any electronic engineer or any electronic design center to use our business, our models, our design rules, our libraries, and to design their own application, to simulate their own application, and to create a layout with a standard GDS2 file for us to be able to manufacture the PragmatIC's on the wafers. So that's something we've been working on. We've been working with several key lead partners, and we will be rolling out a generic PDK in a non-to this future. So that's very important to be able to demultiply the design capability. This is an example of what we called an ASSP, application-specific standard product. So it is also a way to validate our technology. So we've been designing and manufacturing for some time now, NFC chips. Similar to the ones that Stefan was mentioning about with NXP that we can see here. So this is likely to be an NXP NFC chip on a traditional tag. we have been designing and developing and manufacturing our own NFC tag on plastic. So this is to validate our technology and to address that specific high volume, low cost than the current traditional electronics can address. The tags with NFC, which ships today, go in very high volume, 5 cents to 3 cents, thereabout. But still, for the very high volume applications, that's still too expensive, and you're not considered to address the few hundred million, few billion, and more capacity. So that's where, for us, being able to design, manufacture an NFC chip in this way allowed us to reduce the total cost. There's several little points to make here. So the traditional tag with a silicon chip uses an antenna, a strap, and a small 500, 400 micron square chip with pads 200 micron square thereabout to attach to the tag, to the antenna. So obviously that has a cost. You have a cost of the antenna. The previous one still, please. Yeah, you have the cost of the antenna, the cost of the chip, and the cost of the integration, the attachment. So with our PragmatIC, we don't need the strap. The chip is the strap. The chip is cheaper. The substrate is cheaper. The integration is cheaper. That's why we can reduce the cost of the tag to price points that allow them to address applications in volume that traditional electronics cannot address. So it's not really competing, so it's opening markets that traditional electronics cannot. So we have two sides, the transistors, the devices, the PragmatIC, and the means to manufacture them. So we have developed, conceived, designed, and manufactured what we called FlexLogic, a fab in a box. To manufacture traditional electronics, you have usually a big manufacturing plant. We're talking few hundred million to few billion dollars just for the plant. And then you can churn out a few billion devices per year. With our approach, because we have much less steps, because we have much lower temperature, because we are processing on plastic, we were able to have all that in a big room size. So basically, FlexLogic is a big self-contained clean room. Everything is automated. The wafers go from process to process, enter at one side, get out at the other side. The idea is that you have a front cost for the manufacturing box that is few orders of magnitude cheaper than traditional electronics. You have also a cost point of the PragmatIC that is 10 to 20 times cheaper, as well as a much faster manufacturing process in day to days, as opposed to weeks to months, 3 to 6 months with traditional electronics. Again, we're comparing things that are slightly different because we're, as I said, we don't address the same products, the same markets, the same volumes, the same cost points, but we have to reference things to traditional electronics. Next slide, please. So that's a tough one to discuss in details, because obviously when we work with partners, one of the first things that they don't want to is to disclose what we are doing with them. So I've listed here some segments or applications that we have projects ongoing. So in pharma, healthcare, beverage, alcoholic or non-food waste or quality management, packaging, interactive or intelligent, primary or secondary, identification, authentication, and some of those can have multiple for one project. Customer or user engagement, so that's an interesting one as well. Toys, obviously, well-being, wearable, and fast-moving consumer goods, that encompasses some of those. On the left side, you have the 25 biggest fast-moving consumer good companies by sales, and obviously we cannot disclose one or two exceptions apart, but we are working with more than 50% of those on project. I've projects completed or ongoing projects with more than 50% of those. Those projects are, as I said, with sensing things, with NFC, without NFC, humidity, temperature, elongation, different types of sensings. So there's a lot of possibilities. And please, if anybody wants to investigate a project, simple email to me, 2 minutes, simple email to me, we'll do to investigate by email very swiftly. Next slide, please. That's the next and last slide. So we are, of course, working with a technical and technological roadmap. So we will be developing more and more of those ASSPs to address specific applications that can be generically sold to multiple customers. Low-cost ASIC, one of the limitations of traditional electronics is that you have a very high entry point to design an ASIC, and to manufacture takes quite a lot of time. With our technology, there's 2 orders of magnitude, it's 2 orders, one order of magnitude minimum cheaper and faster than traditional electronics. Non-volatile memory, that's something we have validated. So we have been working on time temperature indicators similar to the low-cost time temperature indicators similar to the ones that Stefan mentioned. So if you add non-volatile memory, then you can move into data loggers, and as you add NFC to that, you then have a fully interactive, intelligent data logger or time temperature indicator. CMOS is also something we are working on. I've already prototypes to be able to improve the speed and reduce the power consumption. UHF with the Schottky diode to be able to address UHF tags inlays. And very important, we have been and are progressing a lot of building blocks with ICI in Canada, one of them with the printed batteries, the sensors, and so on and so forth, to be able to address and do prototype with all our partners. And this in the view to reduce the cost barrier for any project and to open up markets and applications. And please, if you have any, next slide, please. And if you have any questions, comments, and want to investigate a project, you can just email me and I'll swiftly follow up with you any potential application. Thank you very much.